Good morning students, this is Sudhir, Chemistry Resource Person for CBSE from Sri Chaitanya Techno Schools. Today I would like to discuss about a very important chapter, that is acids, bases and salts. So this is very important chapter I said because we can expect minimum 6 to 8 marks from different board examinations like AP, Telangana and CBSE curriculum. And not only that, we can also expect different questions in Olympiad examinations, that too mainly in the NTSC level 1 and level 2 examinations. Minimum 2 questions every year we can see in the paper. And this is not only important for 10th class children, it is also important for 7th class CBSE students and C batch C3 students and Medicon M2 students and 10th standard Techno students. So in this session I would like to give you clarity on two important conceptual areas. One is, what do you mean by an acid, base and salt, and other factor is how can we determine the nature of these substances, or how can we identify these are acidic, basic or neutral substances. Here first of all I would like to give you important examples. Here you can see on the board. Here if I take hydrochloric acid, upon dissolution in water it will form H plus hydrogen ion and Cl minus ion, chloride ion. In a similar way, sulfuric acid H2SO4 if I take and dissolve in the water, we can observe the formation of 2 H plus ions and SO4 minus 2 sulfate ion. And phosphoric acid H3PO4, when it is dissolved in the water, it gives us 3 H plus ions and phosphate ion. So here children, what common factor we can observe in all these three chemical reactions? The common factor we can observe is the formation of H plus ions when these acidic substances are dissolved in the water. So based on this we can easily define what is meant by an acid. Acid is a substance which can produce H plus ions as the only positive ions when they are dissolved in the water. Okay, so here I am telling you the acid is a substance which can produce H plus ions as only the positive ions when they are dissolved in the water, is called as acid we can say. And here one more important term you can see on the board, that is a basicity of the acid. From these reactions only I am going to explain the basicity of the acid. Here HCl if I take, it is producing 1 H plus ion, and sulfuric acid H2SO4 it is producing 2 H plus ions, and phosphoric acid is producing 3 H plus ions. Now simply we can say that the number of H plus ions which are produced by one acid molecule when they are dissolved in the water is called as basicity of the acid. Here the basicity of hydrochloric acid is 1 and the basicity of sulfuric acid is 2 and the basicity of phosphoric acid is 3. In the similar way, when it comes to the bases also, just let us observe these chemical reactions first of all, then we can go for the definition of bases. Now sodium hydroxide, when I am dissolving in water, it is producing sodium ion and OH minus ions, and in the same way magnesium hydroxide if I dissolve, it gives magnesium ion and 2 OH minus ions or hydroxyl ions. And aluminum hydroxide upon dissolution in water, it gives us aluminum ion and 3 OH minus ions. Just like in the case of acids, even here also when we are dissolving bases in the water, we can observe the formation of a common ion, that is nothing but OH minus or hydroxyl ions. So based on these chemical reactions we can simply define the base as the substance which can produce only OH minus ions as the negative ions when they are dissolved in the water. These are called as bases. And coming to the bases, another important term also we have to know, that is acidity of the base. So what do you mean by acidity of the base here? So just like in the basicity case, in the same way for acidity also we can define based on the number of OH minus ions produced. So here sodium hydroxide if I take, here it is producing only 1 OH minus ion when it is dissolved in the water, and magnesium hydroxide if I dissolve in the water, it gives us 2 OH minus ions, and aluminum hydroxide it gives 3 OH minus ions. So simply we can define the acidity of the base as the number of OH minus ions which are produced when a base molecule is dissolved in the water, that is called as acidity of the base. And the next one is salts. So here I am giving you one example to define the salt. We all of us know very well how the salt is formed. So it is always formed by the result of neutralization reactions. So here I would like to ask you one question: what is meant by a neutralization reaction? So here the reactions in which acids will react with a base to form salt and water. These type of reactions simply we can say as neutralization reactions. Okay. So here hydrochloric acid is an acid I am taking as an example, and when it is allowed to react with a base, that is sodium hydroxide, we can obtain sodium chloride as a salt and water as a product. The general reaction also can be represented like acid plus base gives rise to salt and water. So earlier I said it is always formed by neutralization reaction. I am asking you one question now: what is meant by a neutralization reaction? So here a neutralization reaction is nothing but acid and base to form salt and water, we are telling. But why we are calling it as neutralization reaction? Because of formation of salt or because of formation of water? Here it is not because of the formation of salt, but it is because of the formation of water. Here you can see the other equation: H plus reacts with OH minus ion to form water, which is a neutral compound always. So since the formation of water, which is a neutral compound, is possible in all the cases of acid and base reactions, we are calling it as a neutralization reaction, but not because of the formation of salt. Here in this reaction, if you observe, the acidic character, that is nothing but H plus ions, are getting neutralized by OH minus ions, that is nothing but basic character, to form a neutral compound water. So far we are discussing about the acids, bases and salts. So I am asking you question now, where we can see these substances in the nature, or where we can observe. So these chemicals we can also see or observe in our day-to-day life, even at our home in the kitchen. So now just I am giving you one example. Let us take one lemon and just try to taste the lemon juice. How you will feel? Yes, it is very sour in taste. So that we can say lemon contains acids, mainly example citric acid we can say. And in the same way, sometimes when a mother cooks bitter gourd, generally we don't like it. Why? Because it is somewhat bitter in taste. That means it contains basic substances, hence it is bitter in taste. And the most important chemical which gives a very good taste for our food materials, that is common salt. If you taste, it is salty in the nature. So like this, whatever the chemical substances observed in our daily life, we can taste them and we can decide the nature of these substances like acidic, basic or salty substances. But here my doubt is it possible to taste all the chemicals? No, it is not possible. Why? Because few chemical substances are very dangerous and harmful to us, and they will show some harmful or toxic effects on our body. Hence we have to go for another option in order to decide the nature of these chemical substances. So indicator is a chemical substance or a dye which can represent the nature of chemical substances into acidic, basic or neutral in nature. So let us see the important examples of the indicators which are generally we are using for the determination of nature of chemicals. Based on two important factors, we can categorize or classify the indicators. One is color change and the second one is odor or smell. So these two factors are the main working principles, the way how we can determine the nature of chemical substances. So if I come for color change, based on color change we can classify the indicators into two important types. One is natural indicator and the second one is synthetic indicators. So here comes natural indicators, mainly we can see litmus, turmeric and China rose indicators as well as red cabbage extract. These four are very good examples for natural indicators. And when it comes to the synthetic indicators, two most important indicators we are using. one is methyl orange and the second one is phenolphthalein indicator. And as I said before, few indicators they also works based on the sense of smelling or odor. So these are called as olfactory indicators, and the best examples for olfactory indicators are onion extract, vanilla extract and clove oil. As we have discussed before, here three types of indicators we can see. One is natural, second one is synthetic and third one is olfactory. And we know that natural and synthetic indicators mainly work based on the color changes, and olfactory indicators are worked based on smell or odor. So let us see what type of color changes we can observe by all these indicators in acidic as well as in the basic medium. Now coming to the natural indicators, here the litmus, turmeric, China rose and red cabbage. These are the four important natural indicators I would like to discuss, and they along with their original color also we need to remember. So here the original color of the litmus indicator is purple, and a turmeric indicator is yellow, and China rose indicator is light pink, and red cabbage indicator is in red color. So these are the original colors of the natural indicators. Now let us see, when these natural indicators are in contact with either acidic or basic medium, what type of color changes we can expect or we can observe. So here litmus indicator, originally it is purple, but in commercial aspects it is available in the form of red litmus as well as in the blue litmus form. If I dip a blue litmus in the acidic medium, red color is observed, and in the same way if I dip red litmus in the basic medium, it turns to blue. So now what we can conclude here is, litmus indicator can produce red color in the acidic medium and blue color in the basic medium. And next one, turmeric indicator. It is originally yellow color we know, and in acidic medium it is remains as it is, there is no change in the color, and in the basic medium it turns to reddish brown. And coming to China rose indicator, the original color is light pink, and in acidic medium it turns to the dark pink, and in the basic medium we can observe green color. And red cabbage extract also very similar to remaining natural indicators. Original color of red cabbage, as I said, it is red in color. In acidic medium it remains as it is, there is no change, but in basic medium, very similar to China rose indicator, we can observe the green color even for the red cabbage extract. So these are best examples for natural indicators which works mainly based on the color principle. And the second category is synthetic indicators. Already we know there are two main or most important examples. One is methyl orange and the second one is phenolphthalein we are telling. So original color of methyl orange is orange. In acidic medium it turns to red. When it comes to the basic medium it shows or develops yellow color. And phenolphthalein, originally it is colorless. In acidic medium there is no color change, it remains as it is in the colorless form, and when it comes to basic medium it is pink in color. These are synthetic indicators generally we can observe. And coming to the third category, olfactory indicators. So here I would like to generalize the observation of these indicators, since these are works based on smell or odor. So what general conclusion we can give here is, in acidic medium the smell of these olfactory indicators can be detected as it is, but in the basic medium the smell of olfactory indicator can be destroyed by the bases. So here I will conclude the olfactory indicators, either onion extract, vanilla extract or otherwise clove oil. In acidic medium the smell or odor can be detected as it is, but in basic medium the smell or odor will be destroyed. So all these indicators, either natural indicators or synthetic or olfactory indicators, are mainly useful in order to decide only the nature of the substance, whether it is acidic or basic, we know that. But here is a question for you. If I give you two different acidic substances or two different basic substances, can you decide which one is more stronger acid or which one is more stronger base? Is it possible by using all these indicators? No, it is not possible, as these are having certain limits and these are short range of indicators. But if you want to decide that nature of acids, which one is more stronger acid and which one is weaker acid. In the same way, in case of bases also, we have another kind of indicators. These are very important indicators to decide the strength of acids and bases, that is pH scale, and the second one is universal indicator. Here I would like to tell you the basic difference between pH scale and universal indicator first of all. So coming to the working principle of these two indicators, pH scale mainly works based on H plus ion concentration present in the solution, and universal indicators works mainly based on the color changes as per the pH ranges. That is the main principle involved in these two indicators. And here let us have a discussion on pH scale in detail. So as I said, the pH scale mainly works on H plus ion concentration in the solution. Mathematically, in a simplified manner, we can express the pH of the solution as the pH is equal to negative logarithm of H plus ion concentration, and we can simply represent like negative log of H plus ion concentration. And in the same way, pOH of the solution can be represented like negative log of OH minus ion concentration, and pH plus pOH is equal to 14. So these are basic formulae which are very much helpful in order to determine or calculate the pH of different solutions as per the concentration of either H plus ion or OH minus ions in the solution. Here I would like to give you clarity. If I take a neutral solution, what type of concentrations are possible for acidic H plus ion concentration and OH minus ion concentrations? First we need to know. So here, if in a neutral solution, H plus ion concentration is equal to 10 power minus 7 molar, and OH minus ion concentration is also equal to 10 power minus 7 molar. So this is the condition in neutral solution. Whenever these two concentrations are altered in the solution, automatically the nature of the solution may be changes into the acidic or into the basic nature. If you observe this representation of pH scale, we can very clearly observe or see the concentration variation of H plus as well as OH minus ions. Here the above one indicates the variation of H plus ion concentration in the solution, and the below one indicates the variation of OH minus ion concentration in the solution. As I said before, here it is 10 power minus 7 in case of neutral solution for both H plus as well as OH minus ions. Now let us see, if I move from right to left, how the concentration of H plus ions will be varied. So it is 10 power minus 7 in the neutral, and it keeps on increasing like 10 power minus 6, 10 power minus 5, minus 4, like that it reaches to 0. That is increase in the H plus ion concentration in acidic solution. At the same time, with increase in the H plus ion concentration, the OH minus ion concentration also will be decreases. Here 10 power minus 7 is in the neutral solution, and it decreases to 10 power minus 8, minus 9, minus 10, up to 10 power minus 14 it will reach. So now what conclusion we can derive here is, based on this variation, in case of neutral solution, the H plus ion concentration and OH minus ion concentration will be equal. Whenever these two concentrations are changed, the nature of the solution will be turns into either acidic or basic nature. And here I would like to give you an example. How can we calculate the pH of acidic solutions and basic solutions? For example, as I told here, the pH of the solution is negative logarithm of H plus ion concentration. In case of acids, directly we can calculate from H plus ion concentration. So let us take one example. In an acidic solution, the concentration of H plus ion is 10 power minus 5. If I substitute the concentration of H plus ion in the expression, how we can simplify this? It is negative log of H plus ion concentration. So 10 power minus 5, if I substitute here, it will become 5 will be the pH. So whenever the H plus ion concentration is 10 power minus 5, the pH of respective acidic solution is 5. In the same way, if I take H plus ion concentration as 10 power minus 3, and the pH will become 3. So like that, in acidic solutions directly we can substitute the H plus ion concentration so that we can obtain the pH value. But in the case of basic solutions, it is not possible to calculate directly as H plus N concentration is very less. Here you can see 10 power minus 7 to 10 power minus 8, 10 power minus 9. That means in basic solutions, the H plus N concentration keeps on decreasing. So these values are not sufficient in order to calculate the pH value directly. Hence, first of all, we have to find out the pOH of the solution by using the OH minus N concentration, so that basing upon pH plus pOH is equal to 14, we can easily find out the pH of a basic solution. And second one is universal indicator we know. So this universal indicator mainly works based on the pH ranges and color changes, as I said. So as per certain ranges of the pH values, we can observe different colors in different acidic or basic mediums. So now here if I observe, we know that the range of pH scale is from 0 to 14. We know that the range of pH scale is from 0 to 14. So at certain pH values, we can observe different colors, and the major colors what we can observe in this universal indicator is, it is very similar to our VIBGR. During the rainbow, we can see 7 colors in the VIBGR. These colors are like violet, indigo, blue, red, orange, green, like that. So here I wanted to correlate the VIBGR with the universal indicator. So here you can see on the board 0, 1, 2. These are the 3 pH values. In these pH values we can observe red color, and a pH 3 we can observe some transition in the acidic character. That's why the color change or intensity will be changes, that is from reddish to orange color change we can observe. And when it comes to 4 and 5, we can observe orange and yellow colors. When it comes to neutral solutions, we can see the green color in the universal indicator. And coming to basic medium, we can see 3 important colors like blue, indigo or purple, and the final one is violet. So here pH 8, it will be somewhat greenish blue, 9 and 10 it is blue, 11 is bluish purple, that is nothing but indigo, and at 12 it is completely indigo or purple, and 13 and 14 we can observe violet color. So like this, these are the colors we can observe in case of universal indicator. As per the color change produced when we are testing either acidic or basic or neutral solutions, we can easily determine the approximate pH of certain solutions. Here I have a question for you again. So why we have to study the pH scale? You may have the doubt in your mind. So let me explain. So why we have to study the pH scale is, it is having some importance in our day-to-day life. So if you go for the applications of pH in our day-to-day life, the main important applications are listed here. The first one is digestion of food, second one is soil treatment and growth of plant, third is tooth decay, and the fourth one is self-defense by plants and animals. So coming to the digestion of food, sometimes we may take some more quantity of food or some spicy food materials. In such cases, our stomach releases more HCl that results in the production of acidity and burning sensation in our stomach. So how can we neutralize that acidic nature in the stomach? By using different antacids like sodium hydrogen carbonate or sodium bicarbonate. Very simply we can neutralize that acidity in the stomach. These are called as antacids. Antacids are nothing but mild basic substances. Best examples for antacids we can say sodium hydrogen carbonate, aluminum hydroxide and magnesium hydroxide. And soil treatment. The growth of the plant is mainly good in pH range of 6.5 to 7.5. Almost it should be neutral in the nature. So whenever soil is having either pH acidic or basic, by using the opposite substances, of basic or acidic substances, we can neutralize that soil pH so that the growth of plant will be good. And tooth decay. Whenever the pH of mouth decreases to 5.5 or less than 5.5, the acids present in the mouth will react with the enamel on the teeth, that results in the tooth decay we know. And a few plants or animals, mainly ants, or honeybees, if you observe, when they sting on the skin, we will get some pain. So because they will release some acidic substances like formic acid, that's why we will get pain. So whenever that pain is caused, we can use some mild bases to rub on the skin so that it will be neutralized. So like this, there are different applications we can observe in our day-to-day life from the pH. So based on this pH concept, in our board exams, we can expect very important model of questions under 3 marks category or 4 marks category. Not only in the board exams, in the NTSC examination also, important MCQ type of questions will be framed. So here I am taking one good example. It is given in NCERT board examination for 3 marks category. So let us take 4 different solutions A, B, C, D with a certain pH values. Okay. So now these are the 3 important questions they have given in the exam. First one, arrange them in the increasing order of pH. Second one is arrange them in the increasing order of H plus ion concentration. And third one, they are asking to identify which one is more acidic and more basic. So this is very important model and very simple question to answer if you understand the concept of pH. So as I said before, the H plus ion concentration is inversely proportional to the pH value. With increase in the pH, we can say the H plus ion concentration will be decreases. So based on this fact, we can easily arrange, and pH value anyhow here it is there. So 2, 6, 8 and 11. So simply we can arrange them in the increasing order of pH. That order will be A, B, C and D. When it comes to the H plus ion concentration, here with increase in the pH value, H plus ion concentration decreases. So a quite opposite order we can get here. Then it will become D, C, B, A will be the increasing order of H plus ion concentration. And finally, as per the pH, we can say that the solution which is having less pH or least pH will be having more acidic character, and highest pH will be having more basic character. Then the most acidic solution is A and most basic solution is D.